Thank you. You're too kind. Yes, I'm Gleb Bahmutov. I'm also a youth soccer coach. And my son, because we're training for August tournament, I'm coaching the team, and I had to find a sub for yesterday's practice. And my son told me that I'm a better coach than that coach, so I'm already good. Okay.
Okay, you're better than all of us. Thank you for making us all feel ashamed.
Okay. Before I begin, I just want to take 30 seconds and show a picture of New York City a couple of weeks ago. Because of wildfires caused by climate crisis in Canada, the whole eastern seaboard could not breathe. And it's not going to get better. And in 5 years, think about what air you're going to breathe, what food you're going to eat, what water you're going to drink. We can survive, but we have to act together. So find an organization in your town. There are lots of them, and only by fighting together we can actually survive on this planet in 10, 20, 30 years. Okay, now on a more positive note, this conference is about developer experience. This is my developer experience. Why doesn't this work? This is what I experience every freaking day. More often is, it used to work, now it doesn't work. Right? This is experience we all share. And I think testing actually helps to prevent that. And my talk is about testing and the experience of writing tests, and mostly about JavaScript. You know why? I'll get to that in a second. But I think testing is broken, but testing will be all right. I'm a very positive person, so we'll finish on a positive note. I'm Gleb Bahmutov. I had a long journey through different programming languages. I blog. I have a lot of GitHub projects. And I do work at Mercari, US. As you can see from my attire, I come from tropical resort city of Boston, Massachusetts, where I live. It's a joke. But Mercari is an online marketplace. We're in Canada. We did not expand into Canada, even though we thought about it, so you're safe for now, but it's an online marketplace. I have a bunch of presentations where I describe how I run testing, because I'm responsible for web testing. So I have a bunch of talks just about testing inside large enterprise. And I run about 700 end-to-end tests many times a day, and today I looked and one of them failed. So I'm not perfect. I apologize. I also have online courses, because teaching someone how to do something actually makes me learn it better. Okay, pop quiz. Some people talked about ChatGPT, Threads, and said, oh, these are very popular apps. Here's a screenshot of an app that is the most popular by far. It's installed on every smartphone, every computer, every operating system. Does anyone know what this is? What app is there? No? It's the first web browser. Yep. And then it became like Netscape and everything, right? So this was created in 1991. It's younger than some of us here, right? But not by much. It's amazing how popular the browser became. And if you ask me, why is browser so popular? Because it's not only for reading the news, right? It even mimics itself and becomes your code editor, VS Code. It mimics itself and installs itself as a music program on your desktop, which is Spotify. Like, the browser is so powerful, and if you ask like Stefan, he'll say, oh, because CSS makes everything. No. The browsers became the dominant programming application platform of today because of this clownish language. Right? Nobody takes JavaScript serious. And why should we? Right? It was created in 10 days. It named itself after Java just to kind of attach itself to Java's hype and applets. Anyway, if you look at JavaScript and ask you, here's like an array of numbers, can you multiply each item in this array by this constant and then print the results? And ask you to write it. You can write it in many, many ways. I have a whole repo where I show like 30 different ways of writing the same thing, but in different styles and using different features of JavaScript. Majority of people will write it like this. Imperative style comes from C++, Pascal, you name it. You have a variable k, you iterate, you increment the variable, and you multiply, and you print. It's fine, normal solution. Like, I'm not going to hire you, but I'm just joking. I'm not going to hire for many other reasons. But I would write it slightly differently. I would notice that multiplication, especially by a constant, is kind of common operation, so I might have a little function called multiply. And I could create multiply by constant by using partial application that's built into JavaScript. And then I could have my array of numbers, and I would use that map, and I would have that for each, right? So there are functional bits in JavaScript, and there are kind of object-oriented bits also in JavaScript. And this is because JavaScript was created as this unholy hybrid of scheme and self. It's amazing, right? One person takes 10 days and screws up the whole world forever. OK, but all jokes aside, I usually take arrays. Arrays are very useful. You can iterate over them. There are built-in methods, and I would write numbers that map, multiply, that for each. But you could also use intermediate variables, right? Every method call, like that map, will give you a different array. But usually we don't write them, right? It's the same. And so I could map, filter. Now there are more methods added, then reduce. Where does the value get stored or produced, right? At the end of the day, all these methods are synchronous. So I could get x, like the value produced by the whole chain of operations, into a variable, and I could use it right on the next line. But what if my computation is not synchronous, but asynchronous? Now, JavaScript is meant to run in a browser which has a single loop, event loop, which means you cannot just block it by waiting by something, because you're blocking the compute. You have to schedule a callback and say, OK, once you're done computation, give me the result in this callback function. So now I say compute, give callback function, it will receive x. Now, mine's broken because I can no longer use x in the next line after calling compute, because it's not there. And this is where people are having problems. Because all of a sudden, how the program is written is not how it's going to execute. OK? Well, you're a very smart crowd, so for you it's easy, I see. What about testing this whole thing? If computation is synchronous, then every testing tool in Node or just JavaScript, like Mocha, Tap, you just get the array, and you use expect this array to deep equal, because you want to compare each item in this array to whatever is there. What about asynchronous computation? How do you test that? So all the frameworks, because JavaScript is all based on callbacks, they also added a feature where will give you an argument called done, usually. And if you can use the done to call the test framework saying, I'm done. The test is done, right? And if you don't call it, they usually have a timer and says, never called me, you fail. OK. Unfortunately, using callbacks, like in JavaScript for the first 10 years, is complicated, because they kind of pollute everything. If one computation uses callback, then you have to pass callback, 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 and then callbacks are everywhere. And it's really hard to program without making a mistake. OK, so it gets better, I promise. OK, you can see, yes. The joke slowly rolled all the way to the back. OK, the promises are not the value x, right? The promise is this wrapper, but at some point we'll get a value. And it has a standard way of attaching callbacks, that then, if it's successful, or that catch, if there is an error. OK? So it first became like a user space solution, like deferred and everything, and then it became part of a language. Because JavaScript, despite being this clown on unicycle, actually has a very standard and good way and working way of improving itself year after year after year compared to every other language. OK, well, let's go back to our array. We can use promises, for example, to iterate over arrays, and, for example, print and multiply number every second. OK, how would you test that? Well, every testing tool not only supports a callback done, but now, if you return a promise, the test framework knows I'll have to wait for that promise to resolve. But again, just like with callbacks, if one thing in your computation returns a promise, well, all of a sudden, everything has to understand promises, right? It's kind of like infecting and polluting everything, and now you see promises everywhere. OK. So people didn't like it, and they introduced a sugar called async await. Boom. So what does that mean? You can update your test and say this test function is now asynchronous, and instead of a promise, you can just await, a special keyword to await the value, because you want to get that value. OK, so how does this translate to the web and the browser? So imagine I'm testing a page that is static. I have a list of fruits. Okay, how would I confirm that the fruits are apples, grapes, kiwi? Well, I could write a Playwright test, right? Where I can go to the page, get list items, and I expect those items to have text apples, grapes, kiwi. Now, you might ask, well, I don't think I'll have a static page. Usually, the page is loading something using JavaScript from the server. So imagine the fruits are loading one by one. Every second, there is a fruit appearing. How would you test that? Well, guess what? The same Playwright test would work the same way unchanged. It actually retries right here in the await expect, and if it doesn't see, if it fails, then it just tries again. And maybe by then, the page updates itself, and so on. And we can look at the test report, and we can see that now it takes almost 4 seconds because it takes 1 second to add each element. But if we look under the hood of async await, in our VS Code, if I hover over this to have text, then I'll see it returns a promise. All these async awaits, if I hover, reveal, you know what? They reveal promises, right? Okay, so now you would think, okay, I know how to do this simple test. What if slightly more complicated text? Imagine not only the apples appear, but there is a price. And now you ask me, Gleb, can you test that this list of fruits have prices $1, $2, and $3? Now, if you ask me, if I give you a test, and when I modify things just slightly, then my test should also modify the thing slightly, right? It should not be a jump from like very simple Einstein theorem, right? So let's look at the test now. Ooh. All of a sudden, I have this giant async function where I'm getting the strings, I'm mapping the strings, I'm parsing them, and so on. Okay? And notice another thing. I have to use async await. Now I have to know which thing is what. All right? It's not the same. But under the hood, all I'm doing, I have a function, and I'm passing a callback. And if a callback fails, then it retries again and again. So now you might think, OK, is this the simplest we can do? Right? Why does my test look so weird? And if I forget, like anywhere, async or await, it will fail in very weird ways. OK? So I have a dream to get rid of async and await. OK. The whole problem with testing in JavaScript, and the whole world, really, right? It's not just JavaScript, but the whole problem in today's world is that everyone is greedy. OK, back to the presentation. Now, everyone wants that value x immediately, because it's so much easier to reason, right? Everyone wants to get it, so they can expect that value to have specific value. We used to have promises, and promises, instead of getting the value, we would just pass it forward. You could just get the elements, get the inner text of each, and then convert to prices, maybe parse something, right? This used to be the thing, and for a brief moment in time, a couple of years ago, before we went with async await, people were using functional programming too, where, for example, it's not promises, but they had like options, maybes, tasks, like wrapped values, where instead of getting the value, you say, when you get the value, here's more functions that I want you to run on that value, right? They would like assemble all these pipelines. They could use functional reactive programming where anything could be a source of events. And then you would just combine those like pipelines of data processing. And here's how it looks. And look at the power of this. I'm taking an element, a button, and I'm attaching a click handler. And I'm saying, you are event source. Every time someone clicks, you generate me an event. And then I could have another data source attached to an array. Each item is an event. And then I could use standard operators, like zip, to take two event source streams. Anytime one event generates, or stream generates an event, it will wait for the second stream to generate an event, and then it would zip them up and I could pick which one or combine them. And so in this case, every time a user clicks on a button, it would print a number from an array. Okay? So for a very brief moment, about 2-3 years ago, before async await sugar came, we had this promise object. People were using functional programming like tasks, options, maybes. People were using something like observables. And instead of continuing that and kind of creating these pipelines of processing, people said, too complicated. I just need async await. And that's the end of the story. Because once you introduce this special syntax into the language, it's the end of a line. Right? Now we're thinking, oh, we should also introduce pipeline operator and all this. But once you introduce this, it's very hard to modify and very hard to extend. So the lesson here is sugar is bad for you. OK, back to the regular schedule programming. So let's take this test, right? If an assertion fails, if we don't find the correct prices, we go back to the page and we try getting elements again and trying this. OK, so we know that everything is asynchronous on the web, right? Everything. Fetching data, rendering data, all this jazz. And we know that we have to transform things, right? We're getting elements, but we want that text, and then we want to parse the text, convert to prices, and then assert the prices. So is there a better way to write the same test? Now, this brings a topic that which framework is better, right? Lots of flame wars. I'll tell you which one is better, in my opinion, right? But I'll tell you a secret. The best testing tool is the one you know the best yourself right now. That's the one you reach for. OK? So yes, I'll show my opinion, right? But if you don't disagree, it's fine. I have presentations about Cypress and Playwright, and I have a course. So if you disagree, just buy the course and make me feel guilty, right? Fine. OK, this is the same test, but written using Cypress geared towards web development. So what we're doing, we're visiting, the test doesn't use async keyword because everything is asynchronous. So, OK, we're visiting the page. Again, we're not awaiting because we know we'll have to await. We're getting the list of elements, and we map each element to the inner text property. Then we map invoke, meaning we go through each string and we invoke split method and passing $ as separator. And then we need to get the second item from each array. And then we map each string to a number. So now we have an array of numbers, and we write an assertion. And you might not believe me, but it works. But here it is. Now look at this last line. This is the assertion. Notice it says 1, 2, 3. And once it sees 1, 2, 3, it's done. OK, so the test does retry, does parse the numbers, and does compare them to the expected result. So what we built is a pipeline converting elements on the page, what we find, to the array of numbers that we use in assertion. And if it fails, it just goes back to the beginning of a chain. So if we compare the two solutions, right, it's up to you which you think is simpler. I would say that building pipelines of transformations is pretty simple. And especially if we just look at the visit, like we're opening the page, we're going to the page, right? No, of course the test has to be static, right? Like how can you visit a page with synchronously? No, the page, the browser has to go to the server, get HTML, parse HTML, load whatever resources, and so on. Of course, loading of a page is asynchronous. And of course, the test has to wait for the page to finish before it goes to the next command. It makes no sense to do it otherwise. So the syntax, right, in both test runners, right, Playwright is imperative, declarative, reactive kind of functional programming for Cypress. Both are acceptable JavaScript styles. OK? Now it's I call it Tinder data flow because in imperative you go swipe left. In Cypress, you always pass data to the right. But it's the same as coding using for each loops versus array.map, where you kind of pass everything to the right versus left. Of course, people get mad, right? But again, this is just, if you're familiar with it, you feel fine. But if you're familiar with style on the left, then, but to me, it's like, just think about what you're trying to confirm. Like, don't think about the programming style. Like, what are you trying to test on the page? There should be 2 items. Well, get list of items and write an assertion. There should be even number of items. Again, get items, write an assertion. Well, the number of these items should be the same as the number of other items. You pass it to the left, to the callback. If you can stop network, you know everything, then it's even easier. Okay? So kind of passing everything through the chain. Now, if we go back to the very simple example, right, where we say, OK, the list of items, apples, grapes, kiwi, right, we used a Playwright built-in to have text assertion. Now, Cypress doesn't have it because it uses just chai and chai jQuery, right? But now you can see how you can create this assertion on the fly. You get the list of fruit elements, and you map each one to inner text, and now you have an array of strings, and you just write deep equal, and you are done. Little function of programming. And again, I understand it's frustrating if you're not used to this style of programming. That's why I have like a whole page of just my examples and videos where you can find bigger recipes like this. Because I think if you see the answers, and you see it a couple times in different scenarios, you're like, yeah, OK, now I get it. But if it's the first time, it could be frustrating. OK, I'm going to skip this rant, because I already ranted a lot. So let's go back to a more interesting thing. People argue about tests being slow, or this framework tests in 5 seconds, this one runs in 10 seconds, a minute. Honestly, I don't care, right? How long your end-to-end tests take. Because the solution is not to make a single test faster. The solution is to make all the tests, like the whole 700, in my case, tests faster. And the only way to do it is by running tests in parallel. And in that case, I don't care if it takes 10 seconds or a minute. I'll just spin more machines, and it will take 5 minutes for me, for the whole set. So, but I do care about something else. The most expensive factor in running tests is the human capital. How long does it take me to debug a failed test? This is the true measure. Okay? If I spend 1 hour every day triaging and debugging failing tests, that's it. This is like, it will blow the whole your budget for CI servers and whatever else tools out of the water. Okay? This is the only metric I care. If a test fails, how quickly can I debug it? Okay, so Cypress. The website is on the right. It's like iframe there. You see every command from the test on the left in a command column. The cool thing is that in Cypress, you can click on each command, and it will restore the dump snapshot right here. So you see how application looked. And also, in the command log, it actually prints the inputs and outputs of each command. So I can see what it got and what it did. Okay, so I can do time-traveling debugger for each testing command. If I look at Playwright, it also has this kind of output. But because it doesn't see anything inside this big asynchronous callback, I cannot do much. Now we have UI mode, where you see the test running, and then you have the same output. But again, I don't see anything inside that callback where I'm parsing text and getting things, and so on. So the debugging experience is very, very different. Now, a lot of people are still using Jest and React testing library and mock service worker for doing component testing, right? So here's Jest, React, Jest DOM test, and this is equivalent Cypress test. OK, that's fine. We know the syntax will be different. What is really, really different is the debugging experience. If your Jest fails, it just spews this blob of HTML. And you're what do I do with that? My answer is not in this giant HTML blob, right? But in Cypress, you can just click on each command, see what it did or did not do, and you can quickly understand the problem. Now, this does look OK. And watch the whole video for more examples. But now there are better tools who's ready to go into the future. OK? Replay.io. So they call themselves time travel from the future. And I was like, does it even make sense? Time travel from the future? Like, we're in the present. Like, we're not from the future. But then I'm also thinking, time travel is such full of paradoxes, right? What if we could do time travel, but only into the future? Would you go into the future? And what is the longest period you would go to? Because everyone else is staying here. So would you fast forward 1 year? 2 years? 5 years? Yeah, think about it. Yeah. OK. So replay.io is like incredible debugger that you run on CI. Right? You don't run it locally. You run your tests in replay.io browser, and it records everything, like every command, like every machine statement. OK? And then they show you a replay. And I think that's why they call this company replay.io. I'm not sure. But OK, there's a lot of things going on. And it's just a screenshot from a video, because I think the screenshot actually is more useful to describe it than the whole video. So it kind of looks like Cypress. You see the commands in the command log column on the left. You see how the application looks on the right. But they have this middle column. Remember, this test ran on CI. But once you look at the replay, you click on a command, and all of a sudden, the source for your application opens up in your debugger. And now you click on the click command that the test executed on the DOM element. But now you can step through your application statement by statement how it executed on CI. You can look at every variable value. You can fast forward or go back. And you see, oh, this is why it failed later. This is why, for example, the response here says could not find received undefined. And this is why my application later showed some garbage. It's a debugger that records everything the browser does on CI so that later you can understand the problem. I kind of think of this as, remember The Matrix, the best movie of all linear algebra genre, right? Remember when Neo stopped the bullets and he took one and he looked at it? This is how replay looks to me. Even better, it's me hearing that Neo got hit by a bullet, going there, like time traveling to that moment, stopping the bullets and inspecting each one. And like, oh, this is why this problem happened. This is why my test failed. Good stuff, good stuff. So final thoughts. Here are my predictions for the future. And before I say anything, you might ask, OK, Gleb, you're not a serious person. I mean, you joke a lot, and I agree. But they always said that the jokers, or jesters, right, were the only people allowed to say the truth, right? OK, so here are my past predictions, just so you trust me now. 5 years ago, I said that component testing in Cypress will be huge, and that capturing everything like replay does will be huge, and it will happen. And both were true now. OK, so 5 years, I predicted everything. Last year, I said, Playwright needs UI mode so you can see everything right away as you code. And then I said, well, and Cypress needs the opposite, the trace mode that shows everything. And now this came true again. OK, so here are my predictions today. OK, so everyone get your pens or whatever your writing devices are. OK, here's prediction number 1. It's not important to capture everything. It's easy to record everything, all the network traffic, all the browser thingies, all the API calls, DOM changes, mutations, and so on. You can accumulate terabytes of information from each test run on your CI. That's not the key. The key to good developer experience is to use this information when something fails to quickly explain why it failed by looking at previous successful runs and all the terabytes of information. The first company that does that on scale, or at scale, right, where something fails in your test, and they immediately say, Well, the pixels for this area on your page change, like image diffing. And the network call that loaded used to return 5 items, now return 2. And the backend did this thing, and this is the difference over the permission issue fetching some data. That will be collecting paychecks from everyone. The diffing is important. Capturing all the information where the user has to then sift and kind of understand what is in the logs is not that important. And the second piece of my prediction is that we're kind of blurring the line now, right? So now the testing tools record everything, and we have a bunch of companies like Lightspeed, Sentry, right? Even Full Story, they record everything normally, like when the users use it in production. But which tool is which now, right? If my testing tools can record everything and kind of quickly tell me why something fails, why can't Sentry tell me when something fails, why it failed? Okay? So I think, is Postman a testing tool, or production monitoring tool, or exploratory testing tool? Because they all now have this same kind of capability. So these are my predictions. Let's see. Let's meet again in a couple of years, and you'll tell me that I was right or not. But that's the end of my presentation. Thank you so much.